Hello, welcome to your lesson on the discriminant, where we will discover what this is and also apply it. Okay, in the last lesson we looked at a standard form quadratic which has been set equal to 0 and we try to solve it. We noticed when we try to solve it we end up rearranging items until we get x equals this. This is called the quadratic formula. It's a very important shortcut. It is very useful for solving quadratic equations when we want to avoid the process of completing a square, because this essentially gives us a shortcut right to the answers. Okay, so a quadratic equation in this form, standard form, has what is called a discriminant. The discriminant is often shown using this symbol here, delta, or d, letter D in Greek, and that equals b squared minus 4ac. So that is called the discriminant. As you can see, the discriminant is a portion of the quadratic formula. It is this portion here within the square root. One mistake commonly made by students is to say the discriminant is all of that, but including the square root. It does not include the square root. The discriminant is only this portion inside. Okay, so now that you know what the discriminant is, let's try to find the discriminant for some quadratic. So here's a quadratic. Here's the discriminant again. Can you find the discriminant value for this quadratic? Okay, let's check your work. So discriminant equals b squared minus 4ac. This squared, negative 6 squared, is 36. This is 24. So we have 36 minus 24. The discriminant value is 12. Okay, I want to show you don't have to do this part, but if we did the whole quadratic formula on that same one, notice we end up with that 12 under the root sign, right? That is our discriminant, that b squared minus 4ac. So that should match, and it does. Great. Now notice when we solve this also, if we solved it, we have two answers. And those two answers we talked about last time are the x-intercepts. They're called the roots. They're called the zeros. They are the x-intercepts. There they are. So if we solve that, there they are. And here, again, the discriminant had a value of 12. Okay, next one. Try this one. What's the discriminant? Okay, setting up d squared minus 4ac, sorry, b squared minus 4ac. We get 25 plus 8, which is 33. Hopefully you were able to get that discriminant value. Okay, again, if we are to solve that quadratic using quadratic formula, we can see, once again, there's our discriminant. Underneath the root, we have our discriminant, so there it is, 33 matches what we got here. And then solving it further, we get two solutions. And when we graph it, there are our two solutions. They are called the zeros, they are called the roots, they are our x-intercepts right there. Try this one. What's the discriminant value for this one? For this one, set it up, and you may have noticed something strange. We end up with 144 here, but also 144, and they're being subtracted. So the discriminant is 0, and that can happen. So in this case, it's 0, but let's see what happens when we solve that. So if we solve that quadratic using quadratic formula, you can see, once again, there's our discriminant. The 0 under the root sign, because the discriminant is under the root sign, matches what we had here. So if you do a square root of 0, that's 0. So we no longer have two answers, right? Because normally we'd have 12 plus something and 12 minus something, but this thing is 0 both times. So it doesn't matter if we're doing 12 plus 0, 12 minus 0, we're getting the same answer. So there only is one answer in this case, and it's 1.5. So what does that mean for the graph? Well, if there's only one answer, then there's only one x-intercept, and we see it right here. So that parabola, if we graphed it, looks like this, and the vertex is the x-intercept. The parabola sits right on the x-axis with the vertex right there. So only one x-intercept, and that's why we saw only one solution here. Very important thing to know. Try this one here. Okay, the discriminant is 6 squared minus that, 36 minus 36, same as the last one. We get a discriminant of 0. So maybe you're already thinking, okay, it's going to be a parabola whose vertex is right on the x-axis. Let's double check. So here, solving by quadratic formula, we get that 0 under there again, which matches our discriminant value. Great. So again, we're left with the situation where we only have one solution, and it is 3. This one, if we graphed it, it's a parabola. This time it's a concave down parabola, but it's still a parabola where the vertex is your x-intercept. That parabola hits the x-axis right there at one point, only one solution. And imagine if this parabola went up just a little bit, then we'd have two solutions, right? But there's only one right now. Okay, how about this one? Find the discriminant. Let's check our work. This time the discriminant is 1 minus 24, which is negative 23. Hey, our first negative discriminant. that we've gotten. So let's see what happens. Here's the quadratic formula solving that quadratic, and there's our discriminant that matches what we found here. But now we have a situation where we have a root of negative 23, a root of a negative number. In the last video we spoke about that. That means there's no solutions, or actually no real solutions. And we can't solve that further with real numbers, right? So what does that mean for the graph? And we talked about that as well. When there's no solution like that, it means there are no x-intercepts, at least real ones, right? So we have this parabola which is floating above the x-axis, no x-intercepts, no solutions. One more, try this one. This one, the discriminant is negative 76. It's negative again. So let's confirm everything works out. Solving by quadratic formula, we get again a negative 76 because that's our discriminant. We cannot take the square root there, at least if we're working in real numbers, so no real solutions. And again, we see a graph where the parabola is floating below the x-axis, concave down, and does not intercept, therefore no real roots. All right, all important points. So here is what we just did. We found value of discriminants. These are the ones from the last 6 we just looked at. We noticed when there's these values, we had 2 solutions. When we had those, there was 1 solution. And when we had these 2 negative discriminants, we had no solutions. So let's fill in this table. If the discriminant, let's see, if the discriminant is greater than 0, in other words, if the discriminant value is positive, then what happens? Then the equation has 2 distinct real roots. That means 2 unique solutions. And these are the x-intercepts. And there's 2 x-intercepts, right? What if the discriminant is equal to 0? How would you fill this in here? Okay, 2 equal real roots. So we still say there's 2 solutions, but we call them 2 equal solutions, okay, or 1 repeated root it's called sometimes. So that was the situation where we had the parabola sitting right on the axis with the vertex right there as an x-intercept. So the vertex still counts as 2 solutions because we can factor it and find that it's a perfect square. Finally, this one, what happens when the discriminant is less than 0? That means when it's negative, like these two. Then we have no real roots and therefore no x-intercepts. So key conclusions, things to know about the discriminant. Okay, let's apply those rules. Now that we know if discriminant is positive, we'll have 2 solutions, or if it's 0, there's 1 solution, or if it's negative number, there's no real solutions. Let's apply that to some problems. Okay, let's get started. Try A here. So you're going to find the value of the discriminant, and then you are going to say the nature of the roots, which means tell us is it 1 solution, 2 solutions, or no real solutions. Okay, in A, let's check our work. So the discriminant is 33. That is a positive number. It's greater than 0. That means we will have 2 distinct real roots. Try B. In B, the discriminant value works out to be 0. That tells us there will be 2 equal real roots. We've been calling it 1 solution, but again, it is actually 2 solutions. They just happen to be the same solution. So that's the situation where the vertex is your x-intercept. All right, this one, let's take it a step further. We're going to use the discriminant to find how many solutions there are, but then we're going to go on and solve it to confirm that we have that many solutions. So find the discriminant, say how many solutions it should be, and then find those solutions. Okay, in this one, if we use the discriminant, we should get a value of 0. A discriminant of 0 tells us there will be 1 solution. Therefore, solving it, we should see that 1 solution. So I'm solving it. It's a perfect square. And that's what will always happen when we have 1 solution. When the discriminant is 0 and we have 1 solution, it's always going to be a perfect square, because those are the parabolas that always sit right on the x-axis with the vertex on the axis. So solving that, we get the single solution of x equals negative 2. Try the same thing here. Okay, so solving the discriminant, we get a value of 576. That is a positive number, therefore 2 solutions. Let's solve it to confirm. So here we go. 6 can be factored out. At this point, you can divide by negative 6 on both sides to get rid of the negative 6. I kept it for one more step. But continuing on, I got rid of it. And then we can solve it and find our 2 solutions. So we were told there should be 2, and we confirm there are 2. Next, with these ones, sometimes we cannot solve by factoring, right? So here, find a discriminant and tell us how many solutions there should be for this one and this one. Don't worry about using quadratic formula. These are ones we've already done when we studied that. Just tell me how many solutions for each. Okay, first one, the discriminant is 12, therefore 2 solutions. If we did quadratic formula, which we did in the past on this one, it produces 2 different answers right here. Second one, discriminant should be -4, which means there will be no real roots. That one we also did with quadratic formula before. It's the one where we got to the end here and said no real solutions because we have a square root of a negative number. And as you may remember, there are imaginary solutions, just no real solutions. Okay, let's take this a step further. Often you'll see problems like this to do with discriminants. It says find the values of k for which this graph has 2 distinct real roots. So 2 distinct means two separate solutions, right? So what is the value of k? What would go here so that this parabola will have 2 solutions? And we need to find that value by saying, well, if there's going to be 2 solutions, we know that the discriminant is going to be positive. So if you take that and you set up the discriminant will be 9 squared minus 4ac, and now we put the k in for c. So you know the discriminant ends up being this. So now we don't have a numerical value for discriminant. We have an expression with a variable, which is okay. Now we know that that must be greater than 0 because we have been given that there's 2 real solutions. Therefore, the discriminant must be greater than 0 because it's a positive number. That inequality can be solved just like an equation. As you know, when you solve inequalities, you can follow the same rules. So we subtracted 81, then we divided by -4. But notice when we divided by -4, the inequality sign changed direction. And that always happens when you multiply or divide by a negative number when you're using inequalities. So there's our answer. For k values less than 81/4, this parabola will have 2 distinct real solutions. Okay, this one is important to look at it in Desmos. So we just found out that when k values are less than 81/4, which is about 20. So when k is less than 20, we will have 2 distinct real solutions. Let's take a look at that in Desmos. So here's that equation with k there. And we learned when k is less than 20, it will have 2 solutions. And we can see right now this parabola does have 2 solutions right there. And k is less than 20. So if I keep k, look, as I'm moving k even lower, values that continue to be less than 20, we continue to have 2 solutions. There's always 2 x-intercepts there, right? But what if I make k greater than 20? Look what happens. As I'm moving closer to 20, the parabola is moving up. And then the parabola is above the axis. So at some point it has 1 solution, but then as k becomes bigger, there's no solutions anymore, no real solutions. So that's what we solved in the last problem, that k must be less than 20 point whatever it is in order for this to have 2 solutions, because that's when the parabola dips down below the x-axis. Okay, so it's always always important to remember the context of what we're solving here. Let's try another one like this. So here's our equation. Let's solve for r so that this equation will have only 1 solution. So do that first. And after that, solve for r so that it has 2 unequals, so 2 distinct solutions. So let's try a first. Okay, if it has 1 solution, the discriminant must be 0. Okay, so find the discriminant, set it equals 0. That means you end up with this equation here. Solve that equation and we get an r value of 1/4. So it's just a matter of picking the correct discriminant, finding it, and then solving for the variable. So now we found out that this one will have 1 solution if r is exactly 1/4. So if I graph that and I put a value of 1/4 in there, this parabola would sit right on the x-axis with the vertex sitting right on the axis. Okay, great. How about b? Try b. Okay, in b, the discriminant must be greater than 0 because we're looking for 2 unique solutions or unequal solutions. So same thing, you set it up, but now it must be greater than 0, and therefore it's the same answer as we got here, right? But now we have a different symbol because we know that r values can be any value below 1/4. So again, anything below 1/4 would produce a parabola that would then cross the x-axis twice, right? Okay, how about this one? Try this one out. Okay, this one, the discriminant must be 0 because we're looking for 1 repeated solution. So there's our a, b. Our b value is -6n, so be careful about that. And our c value is that. So solving that discriminant, we get 2 answers. So this one's a little more complex. Pause if you need to, take a close look. But basically, we end up with a quadratic when we're solving for n. Then we found 2 n values. And now substitute the n value into the original equation. So I put the 5, 0 doesn't count because it's not quadratic anymore, but 5 you can put in there, solve it, and then you should be able to get 2 solutions. So we confirm that there are 2 solutions. Try one last one. Check your work. And these are a little tougher. Pause if you need to. These are a little tougher. Check your work there.